Hello everyone, welcome to week 2 of online learning. I want everyone to know that those who handed in all your assignments did a really good job, and I've been checking those, and hopefully I will get those into the grade book soon. I wanted to take some time here to review some of the topics from week 1. Considering that you will have to take a test on Google Forms this week, I kind of wanted to cover some topics that we looked at while we were actually in class, because these topics will be on your test that you should take this week. So one of the last things we did when we were in school, we had our mineral lab, our mineral identification lab, where we had those 15 different samples. So I just want to review quickly with you what a mineral is. So if you take a look at my screen, I typed up this outline for you on a Word doc. So please follow along with me so that you can be ready for your test. Okay, so if we think back to what a mineral is, it has these 5 requirements, and it must meet all of the requirements. Can't, just be solid and naturally occurring. It has to be all of these 5 things. So we have it has to be solid. Naturally occurring means it can't be made by people. Has to be inorganic, which means it can't contain anything that was living, was part of a living thing, or was ever alive. Okay, we'll talk a little bit about what that means further in this document. It has to have a crystalline structure. So basically that means the atoms themselves have to be arranged neatly in a regular repeating pattern. Now, if you think back to chem, almost all solids have this characteristic. The atoms themselves are tightly packed together. They're not moving very much, so moving at a low velocity or speed, and they form some sort of pattern. So we only have two examples of things that are solid but don't have a crystalline structure, and that's glass and plastic. Okay. The last one, number 5, definite chemical composition. That means all minerals are either compounds, like table salt, so NaCl. Let's see, what's another good one? Another good compound. We can have silicon dioxide, SiO2. That's quartz. So we have minerals that can be compounds or they can be elements themselves. So gold, silver, okay, potassium. So almost all elements, all the solid elements are minerals. So there's only 2 elements that are a liquid at room temperature. That's bromine and mercury. So the noble gases wouldn't be considered minerals as well because they are a gas at room temperature. So we're considering things at room temperature. Okay, so anything that any element that is a solid at room temperature, that's most of them. Most of them are metals and are solid at room temperature. They can be considered minerals. So mineral is either a compound, okay, or element. And this is one of the first questions on your test. Okay. All right, moving on. How does a mineral form? 2 different ways. Crystallization from magma, which is molten material, that's like liquid rock below the surface, or lava, and that's also molten rock above the surface. So it's the same thing, their location is different. And we also have crystallization from when water evaporates. Okay, that can also can form minerals, and this occurs when sedimentary rock forms. So the water in between those layers, so we have sediment that get deposited in a lower lying area, and these layers kind of build on top of each other, and the water gets squeezed out and evaporates, and what's left behind is the minerals, and those minerals cement the rock together. They actually officially turn into rock. Okay, so when water evaporates, when magma or lava cools. How do you identify minerals? Based off their properties. These characteristics are only unique to minerals. We would not describe rocks of having luster, hardness. So some of these will overlap. So yes, we can describe color of rock, but some of these are unique to only minerals. So luster is only unique to minerals. Vitreous, that's the glassy appearance. So this is how a mineral reflects light. Right? So these are the adjectives we can use: glassy, having an earthy appearance, pearly, metallic, looking like a metal. Okay, so this describes minerals only. Hardness, Mohs 1 to 10. 10 is the hardest. 1 is the softest, so gypsum would be really soft. Diamond is one of the hardest substances on Earth with a 10. And we do that with a scratch test. So do you remember the penny and the nail and the glass plate? Okay, so those are the things we used to determine how hard something was. Again, Mohs is only used for minerals, not rocks. Okay, so think back to this. There's a question on your test as well about how you determine the hardness of something. Like if mineral A were to scratch mineral C, but mineral C couldn't scratch A, what does that tell you about its hardness of the hardness of mineral A or mineral C? Okay, we have density, we have color, cleavage, and fracture. Remember that relates to how a mineral breaks. Spelled cleavage wrong. So cleavage was breaking off in the flat sheets. Fracture was irregular break with a lot of jagged edges that has no like pattern to it. So this one we can kind of predict in what shape it will break off, whether it's more rectangular or more square. Okay. We also have crystal shape. So this is the outward appearance. So quartz is a really good example of a mineral having a specific crystal shape. We have other properties too. Some minerals can be magnetic, fluorescent, or even radioactive. In that case, you do not want to expose yourself to minerals that are radioactive. That could damage your DNA, depending on the amount of exposure. Examples of non-minerals: anything that is organic, remains of living things, leaves, eggs, tree sap. That can't be a mineral. Even if it's solid, okay, yeah, it's naturally occurring, but it's not, it's organic. It has to be inorganic. So we can't have that. Liquids or gases. So that could be carbon dioxide, that could be neon, argon, the noble gases. If it's a gas at room temperature, can't be considered a mineral. Okay. Anything man-made, of course, so plastic, steel. Things that are non-crystalline. So we said almost all solids have the crystal structure except except glass and plastic. So the last one was definite chemical composition. We said it has to, minerals are elements or compounds. So that means anything that's a mixture can't be a mineral. Minerals are pure substances, meaning element or compound. So most substances, boys and girls, are mixtures. So cereal, steel, plastic is a mixture, nail polish. A lot of these things are mixtures of different compounds, kind of all put together. That's what a mixture is. Okay. So that kind of wraps up my outline for minerals. We're going to move on to rocks. So we know we have 3 different types of rock: igneous, sedimentary, metamorphic. Rocks are classified into these categories based off the processes that form them. So it's based off their formation. Did they form from cooling of magma or lava? Okay. Did they form when sediment is deposited into low-lying areas, right? And then layers of sediment will build on top of each other. Okay, and the weight of the layers, boys and girls, that's what pushes out the water evaporates, those minerals form, they cement the rock together. So you should be aware that sedimentary rock, when we say deposit in low-lying areas, typically these low-lying areas are filled with water. So that means lakes, oceans. This is where sedimentary rock forms. Or is it metamorphic? So we know this type of rock only occurs underground. So igneous rock can occur either above ground or underground. So if it's underground, we know that it's intrusive. If it's above ground with lava, then it's extrusive. And remember, the extrusive ones, since they cool much quicker, this does not allow for large mineral crystals to form. So we have smaller crystals, and it could take thousands of years for magma to cool, which is insane, because that surprised me myself. I didn't think it would take quite that long. It can take thousands of years. So that means those crystals can grow very large. Crystals can grow large. Okay, so metamorphic, we're going to jump back to metamorphic here, only occurs underground. We know we have heat and pressure, and it does not melt. Metamorphic rock does not melt. Okay, and if we were to ever see a rock that has a ribbon-like appearance or a banded appearance, we would call that foliated. And that we know, if we have foliated right away, that it's a metamorphic rock. They can be either foliated or non-foliated. So we could have marble or we can have schist, which is not foliated. But it can be foliated or non-foliated. But that's one of the signs we can tell right away if we were to have metamorphic rock, if we have those layers. So I am actually going to make another video because the tool I'm using only allows me to take 15 minutes worth of footage, and I'm at about 13 minutes. So my next video, I'm going to review the rock cycle, what happens at each plate boundary. I'm going to review uplift. So that was one of the lessons, how the Rocky Mountains formed. Some of you did a good job there. Some of you didn't really hit it on the head. I'm going to also cover in my next video results that occur at each type of plate boundary, which will also be on your test, and some examples of the essay. I have two pretty good examples here I'd like to show you. Okay, so I will post another video, so please look there so that you will be ready for your test. It is open notes, but it will take you much less amount of time if you understand what I'm talking about in this video. Okay, so stay tuned for part 2 of week 1 review.